Eddy currents. What are eddy currents? These are the currents induced in solid metallic masses when the magnetic flux threading through them changes. Such currents flow in the form of irregularly shaped loop throughout the body of the metal, and their direction is given by Lenz's law. Once again, I am repeating the statement. These are the currents induced in solid metallic masses when the magnetic flux threading through them changes. Such currents flow in the form of irregularly shaped loops throughout the body of the metal, and their direction is given by Lenz's law. Eddy currents cause necessarily heating and wastage of power. They are reduced by using laminated soft iron cores. They are useful in electric brakes, speedometer, induction furnace, and electromagnetic shielding. Now, self-induction. What is self-induction? It is the phenomena of production of induced EMF in a coil when a changing current passes through it. Self-inductance, that was self-induction. Now the self-inductance, or it is also called coefficient of self-induction, and it is denoted by capital L. When a current I flows through a coil, flux linked with it, phi equal to Li, induced EMF epsilon equal to minus d phi upon dt, and that will be minus L di upon dt. Thus, self-inductance of a coil is the induced EMF set up in it when the current passing through it changes at the unit rate. It is a measure of the opposition of the coil to the flow of current through it. Self-inductance of a solenoid. Self-inductance of a long solenoid. The self-inductance of a long solenoid of length L, area cross-section A, and having N turns is given by L equal to mu 0 N square A upon L, and that will be equal to mu 0 N square LA, where N equal to small n equal to capital N upon L. When the solenoid is wound over a soft iron core of relative permittivity mu r, then L equal to mu r mu 0 N square LA. The value of self-inductance depends on the number of turns in the solenoid, its area of cross-section, and the relative permeability of its core material. Mutual induction. It is the phenomenon of production of induced EMF in one coil when the current through the neighboring coil changes at the unit rate. Mutual induction. Now, mutual inductance, and it is also called coefficient of mutual induction, and it is denoted by capital M. If a current I flowing through one coil generates flux phi in the neighboring coil, then phi equal to Mi, induced EMF epsilon equal to minus d phi upon dt, and that will be equal to minus M di upon dt. Thus, mutual inductance of two coils may be defined as the induced EMF set up in one coil when the current in the neighboring coil changes at the unit rate. Once again, I am repeating the statement. Mutual inductance of the two coils may be defined as the induced EMF set up in one coil when the current in the neighboring coil changes at the unit rate. Mutual inductance of two long solenoids. The mutual inductance of two long coaxial solenoids wound over one another is M equal to mu 0 N1 into A upon L, and that will be mu 0 N1 into AL, and that will be mu 0 N1 into pi R1 square L, where N1 and 2 are the number of turns per unit length of the solenoid. L is their common length, and A, capital A equal to pi R1 square, and it is called cross-sectional area of the inner solenoid. Henry. What is Henry? It is the SI unit for both self-inductance and mutual inductance. Inductance is 1 Henry. Now I am going to define Henry. Inductance is 1 Henry if an induced EMF of 1 volt is set up when the current changes at the rate of 1 ampere per second. 1 Henry equal to 1 Weber per ampere. Coefficient of coupling. It gives a measure of the manner in which two coils are coupled together. If L1 and L2 are the self-inductance of the two coils and M is the mutual inductance, then the coefficient of coupling K equal to under root M upon L1 into L2. The value of K lies between 0 and 1. I hope you have liked the video. If you like my video, please like and subscribe my channel. Thank you.